log n base a equals x. This simply means a raised to power x equals n. Here, what this means here is that how many times can you raise a? That is, how many times can you multiply a by itself to give n? For example, if we have log 100 to base 10, this is equals to 2. What it means here is that 10 raised to power 2 is equals to 100. So that's this definition. Log n to base a is equals to x can be written in index form as a raised to power x equals n. This is index form. This one is log form, logarithmic form. Okay, log n to base a equals x. We are going to use this definition now to simplify these problems. Okay, question. Let's evaluate 1 log 32 base 2, 2 log 27 base 9. Number 3, we evaluate log 25 base 0.2. Okay, let's start to solve this. Say working. Number 1, say log 32 to base 2. Remember that log of a number n to base a equals to x simply means a raised to power x equals n. Now from here, from this definition, now we are going to apply here. We say let log 32 to base 2 be equals to, let's say, x. Now from here, this can be written as 2 raised to the power of x equals 32. Now note, we are going to write this in the lowest common base. Like note 32 can be written as 2 times 2 times 2 times 2 times 2. 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. Therefore, 2 raised to the power of 5 is 32. So we are going to write this 2 raised to the power x equals to 2 raised to the power 5. Now here, 2 here and these 2 are equal. Therefore, x equals to 5. So this simply means that log 32 to base 2 is equals to 5. Number 2, we are to evaluate log 27 to base 9. That is number 2. Let log 27 to base 9 equals, let's say, y. Remember, log n to base x is equals to base a is equals to x. This simply means a raised to power x is equals to n. I always talk about this because this is the definition of log. Log of a certain number n to base a is the number of times x by which a is raised to give n. That is, a raised to power x is equals to n. Okay, so from there, from here we say that 9 raised to power y is equals to 27. Here 9, there is nothing that we can raise 9 to, no number we can raise 9 to give 27. Let's say 9 raised to the power 1 now. 9 raised to the power 1 is 9. If you say 9 raised to the power 2, this is 9 times 9, which is 81. So there is no number that you can raise 9 to give 27. So what we are going to do here, we are going to write, this 9 can be written in base 3, and 27 can also be written in base 3. So we say 9 is 3 raised to the power 2, then to power y. Remember, this is 3 raised to the power 2 is 3 times 3, which is equals to 9. 27 is 3 raised to the power 3. 3 raised to the power 3 is 3 raised to the power 3, which is 3 times 3 times 3, which is 27. 3 times 3, 9. 9 times 3, 27. So we have written in the lowest common base. Now this is 3 raised to the power 2 times y is 2y, which is equals to 3 raised to the power 3. Now this one is from this law of indices. We say if you have a raised to the power x, again is raised to the power y. The answer is a raised to the power x y. That is x times y, which is xy. So from here, since 3 here and 3 here are equal, we can simply say 2y is equals to 3, the same as 3. So that y equals 3 divided by 2. That is 2y equals 3. Means divided by 2, divided by 2, this 2 goes, have y equals 3 over 2. 3 over 2. Okay, so remember, we say that y is equals to log 27 to base 9. So therefore log 27 base 9 is equals to 3 over 2. Very simple. We go to question 3. Question 3 says log 25 to base 0.2. Okay, here we say 3 log 25 to base 0.2. Let this equals to n. From the definition of log n to base a. Remember, to base a equals x simply means a raised to power x, which is n. So from that definition, we know that 0.2 raised to power n is equals to 25. 0.2 can be written as 1 over 5 in fraction 25. Yes, 0.2 equals, that is 2 over 10. 2 cancel itself, 1 is 2 goes to itself 1, 2 goes to 10, 5 times. So we have 5 raised to power minus 1, because 1 over 5 is the same thing as saying 5 raised to power minus 1 raised to power n equals 25. Now the law of indices, this says if you have a raised to power minus 1, it is the same thing as saying 1 over a. So that is why 1 over 5 is 5 raised to power minus 1. Now remember, minus 1 times n give us minus n. Therefore, this is 5 raised to power minus n equals to 25. 25 can be written in base 5. Therefore, this is 5 raised to power minus n equals 5 raised to power 2. Because 5 raised to power 2 is the same thing as 5 times 5, which is equals to 25. So since here 5 here equal, that means minus n is equals to 2. So n equals minus 2. minus n equals 2. We divide through by minus 1. So this one go with this one, then we have n equals to 2 divided by minus 1 is minus 2. So remember n here equals log 25 base 2. So from there we can simply say that therefore log 25 base 0.25 base 0.2 log 25 base 0.2 is equals to minus 2. Bye. Never stop learning. Those who stop learning stop progressing.